The PV cycle for an idealized heat engine is shown in the diagram below. Question A. Use information from the graph to calculate the work done during one cycle. It's a useful work and it is equal to the area inside this closed curve. And since it's a rectangle, area can be found just as length multiplied by height or width, and we can see that it's just 8 multiplied by 2 but times 10 to the power of 5, and we can see that it's 16 times 10 to the power of 5, or 1.6 times 10 to the power of 6, or 1.6 mega joules. The next, during one cycle, a total of 1.8 times 10 to the power of 6 joules of thermal energy is ejected into a cold reservoir. Calculate the efficiency of the engine. So efficiency, by definition, it's useful work. It's actually this value divided by total energy in, and this work done by the gas during one cycle, it's the same as the useful work is equal to energy in minus energy out. It means thermal energy or heat, and divided by total energy in. And you can see that we need what? We need during a total of thermal energy is ejected. It means it's Q out, and calculate the efficiency. So if we know work and Q out, we can calculate what? Total energy in, and it is equal to work, useful work, plus Q out, and it is equal to what? 1.6 plus 1.8 times 10 to the power of 6 joules, and it is equal to what? 3.4 times 10 to the power of 6 joules. Hence efficiency is this work, 1.6 times 10 to the power of 6, divided by Q in, this 3.4 times 10 to the power of 6, and it is equal to 0.47 or 47%, and it's the required efficiency. The next question, sketch the PV changes that take place during one cycle of a Carnot engine. And Carnot cycle consists of two isothermal and two adiabatic curves, and it looks like this: 1, 2, 3, 4. So 1, 2, 3, 4. And for isothermal, it means temperature constant. It means for isothermal change of a state of the gas, when temperature is constant, we know that what PV over T is constant, provided mass or number of moles is constant. And if temperature is constant, you can see that P depends on V as some constant divided by volume, and just from mass it looks like what? Like a hyperbola. But for adiabatic, a formula is given in the data booklet: PV to the power of 5/3 is constant. And adiabatic process, it means that no heat, or it's the same as thermal energy. Heat and thermal energy is the same. No energy, no heat to or from surroundings. And you can see that P is some constant divided by V to the power of 5/3. It's 5/3 is greater than 1, so a curve which corresponds to a adiabatic change will be steeper. So for 1 and 2, 3 are adiabatic curves, and 1, 2 and 3, 4 are isothermal curves. And also we need direction. Direction is in this direction. 1, 2, 1, 2, 3, 4, 1 for one cycle. And hence 1, 2, 1, 2, it's isothermal expansion because volume increases. 2, 3, so followed by a diabatic expansion, followed by 3, 4, it's isothermal contraction because volume decreases, and followed by 4, 1, it's again a diabatic but contraction. Its answer for B. State the names of the types of change that take place during one cycle of a Carnot engine. And in general, what is Carnot cycle at all? This cycle, it means a Carnot cycle, sets a limit for the efficiency. So if some amount of gas undergoes a Carnot cycle, we can get the maximum possible efficiency for given temperatures of cold and hot reservoirs. And efficiency for the Carnot cycle, it is given in data booklet. It's T hot minus T cold divided by T hot. And that's all for this question.